Hello everyone, welcome back to the workshop. Today we are looking at the Acmer P2 laser. If you remember a few months back, I looked at the Acmer P1, which is a 10-watt laser, and they're first to the market. And we were quite impressed with its performance in cutting and engraving. Well, they reached out to me recently and said, hey, we've got the new one. This is a 33-watt diode laser, and it's got some new features we're excited to look at. And I hear assembly is a breeze. So if this is something you're interested in, stay tuned. We're gonna jump right into it. All right, so here we have it. This is the Acmer P2, and first thing that we'll notice is that they actually have a very nice retail box with a lot of graphics and information on the outside. It is kind of nice to see that. I know it's not really critical and doesn't matter after you open it up, but it's just a little bit of the polish that you see on these to have a little more finish to the presentation of a product. I mean, that's what intrigues us and draws us in on some things when you're shopping in a store. I know that doesn't happen online, but it is nice to see some of that. And you'll see right on the front, down the bottom here, they're talking about some of the big features on here. So one of the ones I'm interested to see is that it's supposed to be a super simple assembly. They're claiming 1 minute or less. I believe that's to mount the laser module and hook up the power in the air. So we'll take a look at that. They are using the linear rails on the y-axis, so I've seen it on the x-axis at times, and I've seen linear rod used in others. I'd have to go back and look to see if I've seen them used on all of them in these diode lasers. So it is kind of nice to see that. That does help with rigidity. It helps with less maintenance and less wear and tear when you're talking about the rollers, roller wheels on channels and such. But definitely something nice to see here. I like that they're claiming their speed is 30,000 millimeters a minute. I've seen some outlandish claims that are way up there, and they're the 50,000 millimeters a minute, and some of them are more conservative. But I have a feeling this being a 33-watt laser, that 30,000 millimeters a minute is probably very practical. Obviously, at those speeds, you're going to get less deep of an engrave, but as long as it's still can produce a quality engraving, even if it's light at that speed. That's what we'll be kind of looking for there. Now, they do have a variety of power options for this laser. As I said, this is the 33-watt one. I do believe they are listing here that they have a 10, 20, 33, and 48-watt versions. So definitely something for different flavors. I'm not sure the difference in price points on all those, but nice to see some options there as well. And of course, one of the things that we're seeing in a lot of lasers lately is the automatic air assist. So we'll take a look at this. I imagine this is going to get plugged into the laser. The laser is going to have a single power brick. Lightburn will be able to turn on and off that functionality using the air on or off feature per layer. Definitely something I like, even though I tend to run air on most operations, even engraving. I like to not have to forget about it and switch it back on or off. But we'll take a look at how that functions. Sometimes that can be implemented well, sometimes not so well. It of course does have some safety features we'll go over. Obviously it's got the e-stop button. It does have a tilt sensor, flame sensor, things like that, but I don't think it's got, you know, excessive things that sometimes those get in your way as well. Anyway, I think that's kind of our key points we're going to be looking at. So I'm going to go ahead and get this opened up. We'll pull it out, see if we can get it assembled in a minute, and then we'll start testing. All right, I'm not sure about when I'm going to start that 1 minute, because obviously we need to get it out of the box first. So we'll take a look at what comes out of the box, and then we'll see how much actual assembly there is. So always just be careful opening this up. Don't want to cut anything, so I like to just get the tape started. Usually you can tear it. I don't like to drag it all along there. And pop this open. All right, right on top we have a manual. It's fairly thin, so hopefully that just means not too many build steps. And so they do have a cheat sheet of some engraving parameters on the back, and it looks like machine description, installation. Yeah, secure the module, connect to the module wire, connect air. Yeah, so it doesn't look like there's too much in this instruction manual for assembly, so that's looking promising for their 1 minute mark. All right, let's pop our foam off of here. And this is very nicely packaged. Things are labeled well: accessory package, material package, laser module. Looks like we have a toolkit with some hex drivers, zip ties, and a small wrench. Nice that they put it in a plastic container to keep them packaged. The ubiquitous laser safety glasses. They are in at least a nice little carrying case. However, now this, if you've watched any of my videos, you'll know I appreciate they include these goggles. I'm sure they do something, but the best I can tell you is they are a red colored acrylic. There is no rating on here. There's nothing that tells me that they're rated for a certain wavelength or an optical density. So if nothing else, use these, but I will have a link down below to a set of quality laser glasses that you can be sure has been tested and rated for the 455 nanometer wavelength of this and an optical density that should provide you good protection. But if you don't have anything else, definitely wear these. All right, let's get some of these others out. We've got the air pump. It's got some rubber feet, a little air filter on bottom, which is good. I don't see anything to adjust the speed, so I'm guessing this is just an on-off. It is saying it's a 24 volt, power of 10 watts, 25 liters a minute, and the noise of 34 decibels. And then just has a little outlet on here. So your typical air pump, and then guessing this will plug into the laser. Not a lot of length on there, so I'm a little curious how that's gonna go. Sometimes that can limit how you're working with your enclosure. Let's look at the accessory package. It's got some weight to it. All right, okay. We got our power cord. Simple, this is a US plug, goes to like a PC style. And we got keys, micro SD card, USB reader for that, an additional cable. Not sure exactly what that goes to, might be a stepper thing. And then the keys, this does have a keyed lockout. That's another one of the safety features is you can lock it out so that even the power button won't turn it on. You've got your typical USB A to B printer style cable. A lot of people call them printer cables, but you know, the older style cable, it's not a C end, but you know, these are very typical cables, very standard. We'll check to see the length on that. It does look to be a decent length. And then the power brick, this looks to be, so 24 volts, 6 amp output. Yeah, so this has your typical, your cable input, and then the wire that's gonna go to the laser. Looks pretty hefty cable anyway, so they include a material package, which is always nice, especially for people getting started out. They need a few things to test with. Let's see what's in here. All right, so we've got a cork coaster, looks to be about 3 mil thick. We've got a few of these anodized aluminum business card deals. We've got a square, about 100 millimeter or 4-inch square stainless steel, it looks like. Again, this may be, I'm gonna say maybe 2.5 millimeter acrylic. Looks like it's black acrylic. And then these are probably 6 mil or about 1/4 inch, and they are what? We're looking at about 20 millimeters, or what do we got? Like 6 inches, 7, 8, 1, 2, about 8, maybe 4 by 8 inches. A couple pieces of plywood here. Interestingly enough, they give you kind of a test card. I'm not sure that this is specifically off this laser or not, they don't say. But they've given us some starting ranges here. Looks like as far as cutting, and this is probably like 2 mil, 16th inch. They're using millimeters a minute. They got 1100 at 100% power and 90% power, down to 800 millimeters a minute, 70% power. Again, this is just 16 or 2 mil plywood. And then some engraving speeds here. We'll be doing our own cut cards, but you know, it's nice to have some starting points here. And then we do have a couple sheets of this plywood. Again, it looks to be about 2 mil or 16th inch, roughly about 8 inches square. And then we have the laser module. Oh, in this box, pretty decent size. A couple of dings on the front of the box, but hopefully that's nothing. Okay, it's in an anesthetic bag, which is always good with electronics. And here is the module. All right, so here's the module, and it does have this mirrored glass up front, and that's going to be your kind of reflective material to help keep the bright light from escaping so much, but still allow you to see what's going on. Always still use your glasses. They do have the integrated air, and then you can see they've got an air assist cone inside there. This will come off. There's a set screw down in here, and then there's a hole back here to access that. So you will be able to get in there and clean the cover lens and check on things. And then of course your air just comes out on this side. They do have a nice flip down focusing tool. So you'll flip that down, lower down your module. That will focus it on the top. I always like seeing them integrated into the module. Now, I know some people aren't gonna like this. My friend David over at the Clock Shack, there is no way to remove the shroud. This is all one piece, one unit. And so that could cause problems, interference if you have parts that flip up while you're cutting and they could get snagged on here. You know, not the end of the world. You can definitely work around that. And then up top, they do have a little power module here. Looks like a nice plug with some decent bullet style connectors on there for connecting there. And yeah, so one thing, I won't take this off right now, but yeah, underneath here are cover lenses. And one thing that I was glad to see in there is they actually give you 2 spare cover lenses. And these are typical of a lot of diode lasers. These are generally somewhat interchangeable. It's a pretty common part across all of them. So they have a little piece of glass in the top. It's not a focusing lens, it's just a cover lens. And that prevents the smoke and debris from actually staining and damaging your focus lens. So these are things you need to clean from time to time, depending on how, a lot of people ask how long. A lot of people might say 8 hours or whatever. It's going to depend on what you're cutting and how much smoke and debris gets up in there. So if I would definitely check on this routinely, depending on how much you use your laser. If you used it a solid 8 hours in a day, I would definitely clean it after that. But you know, if you use it occasionally, maybe once a week, just take that nose or that air assist cone off and wipe these down with some IPA alcohol and make sure that you don't get any fingerprints and dust debris on there, that they're clean. Put it back on. And then eventually they may get damaged because you get smoke and debris on there, the light hits it, it fuses, can etch the glass, then you would replace it with one of these. So really nice to see a couple of spares included. But in here, it does look like we have a fairly well assembled laser, another piece of foam that is in here. It looks like the other parts are connected, so I'm gonna pull this out, get it set up here, and I believe we're gonna meet that 1 minute assembly time by just installing the laser head and hooking up power and air. So let's get this pulled out of here. Get that set down. Always double check your box for any loose pieces, screws that may have fallen out. I'd always make sure you fully assemble this before you throw away any of these materials, just in case you're missing something, but we look pretty good. So I'm just gonna get this out of the way. And yeah, it's, you know, mostly assembled here. We've got, our cables are zip tied. They're anchored to the back of the gantry. So they're anchored back here. Our belts are fairly tight. We'll need to double check. It looks like they have tightening spots, both front sides here, and I imagine one on one side or the other for the top. Here we do see in here, there's the linear rail they're talking about along that axis, and then one here. So both X and Y axes have linear rails. And yeah, it's mostly assembled. So what we have to do is attach our laser head in here. We'll need to hook up, there's got to be a hose that comes out, let's see, yeah, up front here. So we got our hose that comes up front here. Now, it's kind of short, but you could possibly get some sort of extension on one side or the other if you needed to, but this is going to plug into the laser somewhere. So, all right, I'm gonna get things just shuffled a little bit, and then we'll start our 1 minute assembly. All right, just a couple more things that I want to point out before we get assembling this, just so you know where to look for them. They do have, most of your cables are on the side. So you got your power and your USB on the side here, which is great. I love not having them up on top here. But your power for your air pump comes off the bottom front panel. So you'll see on this front panel, you got your air port here. So this is gonna plug it into the air pump. And then there's this flame switch here. This looks to be a switch to turn on or off the flame sensor, which is actually right on the inside front rail there as well. So a couple things to look out for. And then if you're wondering what this is actually a little Wi-Fi antenna for the mobile app that you can use with this laser. Now another feature that they do have is in the back corner here, we're gonna slowly move this rail out of the way. In the back corner here, you'll see this switch between Y and R, and then the cable. This is where that extra cable that was in the accessory kit that was supposed to plug into there and then plug into your rotary. So you would switch between the Y axis and the rotary just by flipping that switch instead of plugging in and plugging a stepper motor on the frame. All right, I've got all my parts laid out. I've got my tools and whatnot here. So we are going to get to the assembly. It is very simple. There's just 2 pages on here. Very simple steps, so let's go ahead and do this. So step 1 is to take your laser module and you're gonna slide it down into this dovetail, and you are going to use the screw. You need to loosen this up first so that it's not sticking in there, and then you'll slide this down and then simply tighten this up and it will grab and hold. There's step 1. Next, you have your laser power and control up here. This is keyed. The round barrel needs to go to the right side as you're facing the front. You're gonna plug that down in there. Try to push on the connector, not the wires, and it should secure in pretty well, and then run your air over to the side, push that in, and that's gonna grab. If you need to pop it out, just push down on this ring around the outside and that will let go of the pipe. Now, they do provide zip ties and they want you to zip tie this to this little plate back here, so we're gonna go ahead and do that. So we will take this and run it out and then back in, except I'm gonna flip this around so it's running in the right direction. So out and around here, just to help give a little strain relief on this wire, I assume. There's actually 2 slots, so you can do top and bottom if you want. We'll see how it works with just the top one in place here. We'll zip that down, and I'll have to get a side cutter to clip this off. Next, we would hook up our air pump and power. So we're gonna run our air pump power into this port on bottom. We'll just plug that in there, and then this cable will run along the side. And then we'll plug our air pump. If I can see that, yep. We're gonna plug our air pump into that plug there, just press that fit on. And now the only final things is to plug in our power to our power brick, this to wall, and then our USB cable needs to go from the laser to our computer. So you would plug the B side into here, and we'd plug this into the computer. Other than that, we would have to grab our keys and we would put our key in here, push down and turn, and it does come out, which is nice. I like that they have these for people that want to use them, but I hate when they have to stay in the laser to be on. This one looks like you can turn it on and pull it out, so that is great. I'm not sure, I didn't see if there was a place to put the micro SD card, so this may just have the software on it that we can load into our computer. Some lasers actually have a port where you plug that in, and that's for updating firmware and such. I'll take a closer look at that as we get this hooked up, but we're basically set up and installed. Now, I may probably went a couple minutes there instead of just one, explaining a couple things like that, but very simple. I mean, practically, I really didn't need any tools other than I'm gonna clip this off with the scissors or the side cutters, and we may need to adjust the tension on our belts. We'll check that as we get it hooked up to the computer and test it out. But at this point, really, we're gonna go get it set up into an enclosure, get it hooked up in Lightburn, and we'll start our tests. All right, so we have our laser set up in the enclosure. We got it set up in Lightburn, ready to go. And so now I'm going to start some tests. Now they did provide some material in their sample box, but I like to use material that's more common to what I can get around here. And so one of my popular materials is a 3mm plywood. Now I run a couple different varieties. I have some Baltic birch plywood, which is a little bit thicker, but I've also been getting some more of this 3mm or 1/8 inch craft plywood, poplar plywood, such. It's or light ply is what some places call it. It's a lot less dense and tends to cut a lot easier. So we're gonna go with this. I'll probably find some Baltic birch plywood as well, and then we'll step it up to some 1/4 inch material as well. And so I'm gonna start running those materials through here, and we'll compare the results in a little bit. All right, so I have completed some of my initial cut tests here, so we'll start with the top. Now, I did this first one, and the first one you see here kind of came out a little rough, and that's where I noticed that the air pump wasn't coming on, and that's where I have a little note in there that you need the M8 switch to M7 in the profile. Now, there is a Lightburn configuration file on the micro flash card, the micro SD card that comes with the laser. So if you import that to use it with your laser, that will already have that set up. Otherwise, when you're setting up your laser, make sure you switch that over to M8. But once we got the air on, we did go ahead and run the test again. And as you can see, all the way up there to 900 millimeters a minute, we are getting through at 100% power and cutting fairly cleanly, just a little bit of kind of a little bit of extra burn and staining there on the very ends of the cuts, but that's going to be dependent on the various wood you use, how much smoke it's creating, the resins and glues in there. So, but 900 millimeters a minute, really good. And again, this is the light ply or the poplar ply, so it's a little lighter weight than some. So I went ahead and then pulled out some Baltic birch plywood, and I bumped the speeds down a little bit to run this because I knew it would be a little bit harder, a little more dense. But as you can see there, 90 and 100% power, all the way up to 600 millimeters a minute at the top there. We're cutting through, and if I flip this around, I'll show you that those last two squares there, they're actually really close. You could possibly push them out, but I just tried to tap on them lightly, make sure they would come out without any pressure, and those still stuck. So these are some of our numbers. But again, cutting through this stuff at 600 millimeters a minute, or that would be 10 millimeters a second, is a pretty respectable speed for this diode laser. And again, pretty clean, just a little bit of overburn from that resins and such coming out there. So after that, I thought I would step it up, and I grabbed some 1/4 inch plywood. Now this is just kind of your typical 3-ply, real thin top veneer. I don't remember where I got this stuff, but I went ahead and ran the test, and the first one ran very well. We were getting through at 500 millimeters a minute, even at 70% power. So I bumped the speeds up, and over here you can see 100 millimeters, or 100% power, 700 millimeters a minute. We're still just squeaking through, and as I show you the backside there again, they're almost breaking through at that 90% as well. So very impressed with being able to get through. This is kind of your typical whole big box store 1/4 inch plywood with a thin veneer and 3 cores. So cutting through at pretty good speeds. I definitely think you could run this at 600 millimeters a minute, 10 millimeters a second through this pretty consistently and get really good cuts. So of course I thought I would try some hardwood, and this is a scrap piece of cherry for one of my previous projects. Had enough space on there to run a test, so kind of used some of the similar ones as the 1/4 inch, and surprisingly we are getting up to 500 millimeters a minute up here, 70, 80, or 80, 90, and 100% power, cutting through cleanly, and not a whole lot. I mean, if I flip this around to the back, you see those other ones are not necessarily just hanging on by a thread, but these others are cleaned out, cut through cleanly, and we were able just to drop them out for the most part. So could definitely play around with some more hardwoods. Cherry seems to be kind of the middle of the ground for me, so it's a good test. It's not too light, but also not too dense. But nice to know that on some 1/4" material, we do have a variety of options. All right, we got some 1/2" aspen in here. We're going to put this at 250 millimeters a minute, 100% power, and 2 passes. We'll give this a shot. We'll frame it one more. Good to go. Let's see what it does. That one dropped right out. And if you take a look at the cut, it's not too bad. A little bit of charring, a little bit on the bottom side there. Top side's really clean. I think we could probably speed this up and eliminate some more of this char. We're going to take this up to 375 millimeters a minute, 2 passes, 100% power, and see if that does a better job of cutting cleanly. It did drop out. It's a lot cleaner on the outside here, and a lot cleaner on the inside. It's caramelized, not really a whole lot of char. Top and bottom, that's looking pretty good. So 375 millimeters a minute, 2 passes, 100% power through 1/2" aspen. All right, I've got a piece of 3/4" aspen. We've got it focused down a little bit further, but just enough so that it's clearing under the shroud. We're gonna do 375 millimeters a minute, 100% power, and 3 passes, and see if we can get through this. All right, did not drop out. So what I'm gonna do is just not move anything and run it again and see if 1 more or 2 more passes get through it. All right, that was 2 more passes on there, so it was a total of 5, but it did drop through. Both sides here are fairly clean, a little bit of on top. And on here, actually not too bad, not a lot of extra charring, mostly just caramelization, and that worked pretty well. So 3/4" aspen, 375 millimeters a minute, 100% power, 5 passes, and it cuts through. All right, so I ran some engraving tests. The first one is straight out of Lightburn, and I ran this from 10,000 up to 30,000 millimeters a minute, going in 2,000 increments, and you can kind of see the gradient there from 10 to 100% power. And the nice thing is that up at 30,000 millimeters per minute, we're still getting colors at the 40 to 100% power. So if you're just going for a solid color and you want to run at 90 to 100% power, you're still going to get some decent coloration there. Otherwise, if you're looking for a bigger gradient, I think you'd be definitely sticking down to the 10 to 12,000, just so you have some more depth of the scale there. So we might be playing around with some photorealistic engravings in a little bit, but just kind of wanted to get our baseline numbers here. Now, this test does each square individually, and I do put in overscanning, so it helps it try to get up to these speeds. But just to kind of compare, I do run a separate raster file that it scans across the whole thing. This more ensures that it does actually get up to the speeds stated. And so I ran this one from 20,000 up to 30,000, and hopefully here we can see the gradient on this one. Now it does, it is pretty faint in the 20% and below. You can see a little bit in the 30 in these higher numbers, or in the lower numbers around 20,000. But as we get up to 30,000, it really drops off fast. So I think if you're going for kind of solid color, 1-tone engraving, you definitely could run at that 30,000 millimeters a minute. And so I did test that out. I took my channel logo and the Acmer logo. Went ahead and did this. This one's about 4 inches. This one's about 4 by 3, give or take. And this took about 15 minutes. It did my logo first and then did the Acmer logo with their icon. And it is a decent quality. There's enough contrast there to show the detail and the markings. I think personally I would probably slow it down just a little bit, get a little deeper and darker burn into this material though. But at the 30,000 millimeters per minute, we are still able to actually run that and get some engravings, and it just comes out a little bit lighter, and they do acknowledge that in their advertising. So I think it's fair to say that, you know, they're spot on with their speeds. You can do engraving at 30,000 millimeters a minute and get some decent results. All right, so that last montage was me trying out a number of different materials just to kind of show the various things you can do with this laser. So we did this hardwood keychain, definitely worked out well there as wood. We did anodized aluminum business cards. We had in there as well some glass. We used some of the transfer paper that they have, and if I can get that to show, sometimes glass is hard to see, but it gave it just a nice frosting on there. And yes, this is a little off center. I should have taken my time a little bit more with this, but this stainless steel tumbler, we did this at about 3,000 millimeters a minute and 95% power. Took about 9 minutes to finish this out, and did actually come up pretty dark. All right, the last piece on there was this scratch paper, and it has nice coloring in the background, and normally you just kind of scratch through it with a skewer and such, and kids like to make their drawings and such that way, or artists of all ages. But you get your laser settings dialed in just right, and you can burn through that top layer and reveal the colors. All right, so I'm gonna wrap up my review here, but let me leave you with some closing thoughts. I'll do a little bit of a pro and con on this one. Let me start out with a few of the things that maybe I would like to see just a little bit different on this laser. All right, first off, the laser module is very stout, is very nice. The window in the front seems to work very well. However, I do still recommend you wear your safety glasses. However, in those situations where you are working with fine material that might fall through and stick up, or if you're having some trouble positioning and wanting to, say, use a rotary, the fact that that shroud is all one piece and you can't remove it and get at the laser nozzle is going to make a little bit trickier than some other lasers where you can remove that. It would have been nice to see that possibly being removed with a couple of screws or magnets, but it's not on this one. It's not the end of the world. I think it is still a very good laser, and you can see through that fairly well with the power on option in framing. So again, not a big deal, but thought I would point it out. Another thing that I would love to see on here is variable air control. I love the fact that they have that controlled through light burn, that it is powered through the laser, one less plug, and just turn on air on in your layer and it fires. However, I always like to have also a little bit of control over the airflow. I like to always be running air, including when engraving, but sometimes to dial back the amount of air. That positive airflow coming out of the air cone will help keep your cover lens and your focus lens clean, and it helps keep smoke and debris out of the path of the laser beam. Other than that, I think it is a wonderful laser. I do like the fact that they're using linear rails all around. That is a huge plus. 33 watt laser module definitely performed very well in our cut tests, and still performed well in the engraving tests. The fact that they stated it was a 30,000 millimeters per minute engraving, and we were able to still engrave at those speeds, definitely appreciate that they're not overstating its speed and that it's living up to that as well. The laser footprint size is right up there. It's in line with a lot of the others in there. I don't know if they're going to come out with rails in the future to extend it. I know a lot of people would love to see that. So as far as size, I don't think it's a negative. I would just hope to see in the future maybe some expansion, be able to get longer rails on it. So I hope that gave you some good information on this laser. I will have links down below if you are interested in this and want to find out more. The links will be affiliate links, and they do provide a little bit of a kickback to this channel. I appreciate you using those, but as always, no pressure. Just happy to share the information as I get these machines in to work with them. I also want to mention that if you're catching this right away, the beginning of September 2023, Acmer is doing a nice campaign with their users and others that are interested in their lasers, what they're calling Engrave Your Love. This is a contest where you can submit your projects and your ideas and show what you have or would do with the laser. And they're going to pick some winners to give away some cash, give away some lasers, give away some gift certificates. So definitely nice to see them giving back to the community, encouraging the community to be creative. So if you want to check that out, I will have a link down below where you can get involved with that as well. As always, I'll have some links down below to most of the materials used in this review. Many of them may be affiliate links. Again, I appreciate you using them, but no worries. I just want to make sure that you can find the items I was using in case you want to do some of this projects yourself. So check those down below, and always appreciate your support. Leave a comment down below if you have a question. If you found this video helped you out, hit that like button. And if you want to keep up with me and see what else I do in the future, both from video reviews, tutorials, projects, and such, go ahead and hit that subscribe button. You'll never miss out on that. With that, I'm going to wrap it up. Again, I thank you for checking this out. I thank you for stopping by, and I hope you can get out your workshop and make something too. We'll catch you next time.